Section Preview P7, the last section in this chapter, talks about complex numbers. What complex numbers are? We start by define I square to be -1. I for what we call imaginary. So the largest set so far is the set of real numbers. The complex number is the largest set that is known out there that we are introducing now. So when we are asked to simplify square root of 9, you set 3. And then -9, you always set undefined. Undefined over the real numbers. But over the complex, we can simplify it. So how is that? We can write the -9 as -1 times 9. And -1 can be replaced with I square. So I square times 9. So the 9 comes out as a 3 and the I square is an I. So it has an answer over the complex numbers. So any complex number, in general, any complex number can be written in the form z equals a plus bi. Z equals a plus bi. A is the real part of z, and we usually write like this: re of z, real part, and b is the imaginary part of z, so we usually write it im of z. Why we write im? Because re came from the first two letters, im came from the first two letters, imaginary and real. So in complex numbers, we can perform operations on complex numbers. So if we let z, a complex number, 3 minus 2i, and let's take another complex number, call it w, 5 plus I, we can be asked to find how to add these complex numbers or how to subtract them. To add the complex numbers, we get 3 minus 2i plus 5 plus I. 3 plus 5, 8 minus I. To simplify subtraction, how do we simplify subtraction? Z is 3 minus 2i minus, there's like a parentheses there. W is 5 plus I. So what do we get? 3 minus 2i minus 5 minus I. That's a -2 minus 3i when you combine like terms. We can actually multiply them, z times w. Multiply them and simplify. Z is 3 minus 2i. W is 5 plus I. Let's see what we get. 15 plus 3i minus 10i minus 2i squared equals 15 minus 7i plus 2. That's a 17 minus 7i. Remember, I square is a -1, so I negative by negative made it positive, and I combined these together to get the middle one. We can do more practice on this. Let's say perform some operations such as 3i times 1 minus I means simplify it. We're going to simplify, let's say 8 plus 2i root 3 minus -3 minus I root 3. 3i times 1 is 3i. 3i times I, 3i squared. 3i plus I squared is -1 times 3. But I always like to write a number first, then the I. That's called the standard form of the complex number. So it's written in a standard form. What does that mean? It's in the a plus bi form. That's called standard form of a complex number. So we can do the same thing for the next one. We can write this in standard form. So there's nothing in the front, so drop the parentheses. There's a -1 here, multiplied in becomes plus and plus. 8 plus 3, 11, plus 3i root 3. 3 How about 3 plus 2i square? We learned before, if you have a plus b square, the formula, very important, it's a square plus 2 times the first one times the second one, always plus the second one square. A lot of students are going to write it twice and distribute it. That's, you can do that, but you must learn this formula. It's much faster. This is 9 plus 2 times 3, 6 times 2, 12i plus 4i square. 9 plus 12i. I squared is -1, so that's a -4. So that gives us 9 minus 4. We can combine them, get 5 plus 12i. And notice how I wrote the answer in standard form. Another example, 5 minus 3i square. Again, there's a formula for a minus b square, which says the first one square minus 2. First one times the second one, plus the second one square. What do we get? 25 minus 2 times 5, 10 times 3, 30i, plus 9i square. 25 minus 30i. I squared is -1. 25 minus 9 is 16, minus 30i. Now we talk about the powers of I. If we raise I to some power. Keep in mind, -1 to an even power is 1, and -1 to an odd power is -1. And recall what we started with, that I square is -1. So how do we calculate something like I to the 20th power? Is there a way to find what I to the 20th power is? Or let's say I to the 72 power, or I to the 46 power. Well, let's see. Always start with I square. Always. All of them start with I square. I square. Now, what number on the top I can put? Times 2 gives me 20. It's 10. Notice the 10, I squared is -1. The 10 stays the same. But -1 to an even power, this 10 even, it's 1. It says here 1. So it's 1. So I to the 20th is 1. We do the same thing here. What number times 2 gives me 72 is 36. So it's -1 to 36. 36 even, so that gives me 1. What times 2 gives you 46 is 23. So it's -1 to the odd power, which is -1. -1 to an odd is -1. How about if they give us I to the 11th power? I to the 11th. So what's the difference here? So always start with I squared. 2 times what number gives you 11? There's no number, but maybe put a 5. 5 times 2 is 10. And then you need another I. So this is -1 to the 5th times I. -1 to an odd, it's -1 times I. So the answer is -I. So all these powers of I, the answer is usually going to be either 1, -1, I, or -I. But if we have something like this, let's say they ask us to multiply this out. The I square here, the I square is -1. Always replace it with -1. And then multiply the negative out, -I minus 3. But again, don't leave it like this. Rearrange it, -3 minus I in standard form. It's always better to write in a standard form. Now, which of the following is real and which is considered a complex number? Number 1, 25 plus 3i. Number 2, 29. Well, this has an I in it. It's written as a plus bi, so this is complex. This is just a constant. This is a real number. Has no I in it. No I. Another application or anything we can do here, if we are asked to write, let's say, a fraction 1 plus I over 2 minus I in a plus bi form. How do you write this in this form? Okay, how do you write in that form? To write in this form, we take the fraction and we can rationalize the denominator as we did in radicals. When we did work with radicals, we rationalized the denominator. So what you do, you multiply the top and the bottom by what we call the conjugate of the denominator, by switching the middle sign in the denominator. If it's minus, you make it plus. If it's plus, minus. And then what you get? Top times the top, 1 plus I times 2 plus I. 2 minus I times 2 plus I. And what do you get? On the top you get 2 plus I plus 2I plus I squared. The denominator looks like a minus b times a plus b. The formula for this, the shortcut, is a squared minus b squared. So the first one squared minus the second one squared. What do we get on the top? 2 plus 3i minus 1. 2 squared is 4 minus I squared. On the top, 2 minus 1, 1 plus 3i. 4, I squared is negative 1 by negative positive 1. That gives us 1 plus 3i over 5. But guess what? We're not going to leave it like this. We're going to write it in a standard form. How do you write this in standard form? You can split it up. 1 over 5 plus 3 over 5i. That's the best answer. That's in standard form. So again, as a note, what I multiplied by is called the conjugate. So a minus bi is called the conjugate of a plus bi. The conjugate of a plus bi. If they ask us to maybe rationalize something like 1 plus I over 3i, in this case, you multiply top and bottom by just I, or 3i, it doesn't matter, but you're going to simplify it at the end. And what do we get on the top? You multiply 1 times I times I squared. 3i times I, 3i squared. And that would give us I squared is negative 1, so minus 1 over I squared negative 1, so minus 3. Now, remember, we like to write in standard form, so I'm going to rewrite the I minus 1 as negative 1 plus I, then break it down like so. But this can be simplified even more. Negative with negative cancel out, and you can put the negative out. 1/3 I. 1/3 I. That's in standard form.